Hey guys, welcome back. Today we're going to do a simulation tutorial. Simulation zones and the simulation nodes are things I've always kind of been pushing off to the side, and I figured no better way to get more comfortable with it by doing a tutorial. So let's jump in. We're going to be doing this kind of like particle trails tutorial, and it's going to basically make sure that we have some particles. We're going to instance the particles multiple times with some different moving things using a velocity or I guess a different position vector over time. And then we're also going to have those particles over time get a curve instanced along all of them, so we're able to have those beautiful trails. I think I might expand on this over time, and this might be like a multi-part series, but I wanted to give the basic effect for you guys really quick and easy, so that way you can make it for your own stuff, and more importantly, so I can use this for reference for my own work in the future. So I'm going into the Geometry Nodes tab. I'm going to just delete the light and leave the camera. That's fine. So we're doing a new system. We're going to remove the input, and we're going to bring in a simulation zone. So when we're doing simulation zones, usually we're just going to use points, and then later on, use those points to do different things. So right here, we have 1 point in, right? If we make this 20, there's now 20 points, but they're all exactly on the same spot. So an easy way of seeing what it looks like is to move them and displace them before we even get started. So how can we do that? What we can do is we can set an initial attribute. So we're going to do store named attribute, and we're going to set this to be the initial starting velocity of all of the particles, of the position of where they're going. So how can we make sure this is going to make sense? If we go right here, and I guess let's leave it unset for now, maybe. And what we can do is do a set position and make it super straightforward. Even though there's 20 points, let's just start with 1. We'll say 1, and let's do a vector. Let's do an offset. Let's do an offset of 0.1. So now when I push play to just 60 frames, what do we think is going to happen? This point is probably going to go down because this is the vector right here, right? So let's see. Boom. It's going up. Why is it going up? Because 0.1 is positive, minus 0.1. Now let's see. Oh, it's falling. How cool. Okay, so this is the main idea. It's repeating this same action each time a frame is happening down here. So now let's do 20 points. How can we make it so we can see all those 20 points? Initial value right here. Let's just call it velocity. Then let's do a random value. Then let's do a vector. And we can go from -1 to 1, plop it in there, and change this to vector as well. So in order to bring this in, we have to reference this velocity right now. We do a named attribute. We'll say velocity, make sure it's a vector, make sure it's exactly the same name here, so we're pulling it in. And now if we put this here, what do we think is going to happen? Let's find out. It resets the frame, and now they're all kind of exploding out. Bam, bam, bam. We all see 20 points. And this makes sense because all of these points are going from 1 to 1 all around randomly. So now we demonstrated that there are indeed 20 points. They're all kind of going somewhere, and we can reference this initial velocity and pull it into the actual simulation. So what we want to do is we want to make sure that these points all go towards one direction. And the way we can do that is by having another like reference point for it to go after. So let's do a empty for that. Empty plane axis. Grab Y, move it over there. Let's just call this target empty. Nice. GeoNode system, pull in the target empty. So now we have some vector math to do. Let's think about this. So we have two vectors, like this, maybe like this. So the question is, and there's these kind of points over here. How do we get this? It's basically classic, basically calculating the slope. It even looks like this, like rise and run, right? If we take vector A and vector B, if we subtract the two, we're gonna get this vector pointing in the right direction. And that's kind of how we get the direction to move in. It's kind of like we're following the slope. So we're gonna do a vector math, and we're gonna subtract, and we're gonna take this location and this one up here. So we're gonna do a capture attribute, and we're gonna get the position data. And then if we pipe this in, this is now going to be the directional vector of the empty here and all of these points here, okay? So then we need to normalize this. So this is now giving us this full exact distance. We want to normalize it and just get the directional vector. We want it to be like small, like one unit essentially of space. That's quite easy. Vector math, normalize. Now it's all normalized to 1. And then if we pipe this in here, let's just see what happens. It should be all running off after it. There we go. Nice. You can see all the points. They're coming off and running up over there. So that means we have the direction and it's going in the right way. if we were to flip these subtractions, let's just see what happens so you guys can see. I always forget to. So we flip them, and now it's going in the wrong direction. So this is why we need to make sure we have the subtraction matters for the way we're doing it. We want to have, I guess, this be the secondary one. So the target direction you want to go to is being subtracted by the starting position of the object you're moving. It's moving a little bit crazy. We want to add in some of that initial kind of noise from back here. So what we can do is we can mix these two vectors together. So let's take this noise. Let's also normalize it. Let's make a mix node. And let's do a vector. Let's pipe this in, pipe that in. So now we have this initial noise position with the direction we want it to go towards this, and it's going to be kind of mixed together however we want to do it, right? A uniform mix right now. Let's see what happens. It's moving, it's getting there, they all kind of stop. Too much. I think it's looking pretty good, but maybe it's moving a little bit too fast. So after we have it mixed, what we can then do is take this again, pop it in, and scale it. Let's scale it by like 0.2. It's moving a bit slower. It's not even reaching. And actually what we want to do to have it kind of accelerate is we want to have all of this data going into the offset and storing it into the velocity again and just setting it. That way it will go back and take the initial data of all of this and resetting it again. So right now we have this initial velocity. That's all that's happening. So this will kind of add an acceleration effect, right? Because an acceleration is the velocity being added again over and over again. So we're going to do a store named attribute here. I guess we'll just copy this guy. So Shift D. And this is going in here now. I guess this is also going in here, connecting it in nice and through. And then rather than having this be the offset, we can call this right here and pipe it in. So let's watch this. Now it's going pretty quick because it has the acceleration. Let's do like 0.2. We might need to change the mix as well. Let's see how it happens like this. There we go, that's pretty cool. I'm happy with that. Maybe like 0.3. And it's kind of bouncing back, which is cool. And so as we move it around the next iteration, we'll kind of follow it to the ends of the earth. The base effect is essentially done. The particles are moving how we want them to move, and now all we gotta do is keep on instancing particles. So a quick little trick of kind of doing this is stacking simulation zones. So right now we have a simulation that's just moving the particles after this empty object, right? But if we do this and say a join geometry, we will then stack the particles in and on themselves. So the particles we see here for each frame will then be added on to the join geometry again and moved through. This simulation is doing nothing other than just accumulating more and more particles. So let's watch what happens. There we go. And now we have these little trails. So then the very last thing is just turning them into curves. So we can say point to curve. Now everything's kind of instanced on itself. That's not what we're wanting. We want to have the group curve ID right here, the curve group ID. Make sure that we have it go one curve for one point. We'll double check this inside the spreadsheet to see the points. It'll make more sense. So we're going to do a capture attribute, and we're going to say index. Store named attribute so you'll be able to see it better. Store named attribute, and it's going to be an integer. It's going to be this. And we're going to say curve ID. Yeah, whatever. Curve ID, it's fine. So let's look at this. Points. Nice. So for curve ID, we see 0 to 19, which makes sense because that's 20 points. And essentially for each frame of this animation, it's storing this data of all these positional things and velocities to those exact curves. So then if we route this, then say named attribute, integer, we copy this and paste it and put it in here. We're now going to have all of those curves flow seamlessly because it knows which group ID is for each curve. And now the last thing to do is to turn them into meshes. So curve to mesh, curve circle, I'll say 0.5, and then set curve radius, And a really easy way to do this is just to use a spline parameter. And I like using length, so that means the longer it becomes, the more of the curve you will be able to see. So let's watch this. And it kind of has a fun plant-like growing effect. So actually, let's just get out of this completely so you can kind of see the effect better. Isn't this cool? You can play with it and kind of do whatever you want, and it will just follow wherever this goes. Let's do a quick material to give you guys something before we leave. So set material, shading. Really easy to do this. Is just do a glass BSDF. I think the easiest way of doing this is just do a Fresnel node. For now, we're gonna do a math. And this is gonna basically just make sure we can get just the edge of it, right? So if we do this, so now we have that kind of mask right here with the Fresnel node. And then mix shader. This can go into here. This can go into here. That can go into here. Actually, probably swap these guys. And then in here, we can do an emission. And it can be kind of like a trippy effect with a kind of this like glowing core inside. Nice. Obviously, for the materials, you can kind of go indefinite, trying to make it work. So I would just kind of stop when you think it's like reasonable. Actually, I can have it be unique colors. This is something that's out of attribute. And if we go back into here, what we can do is we can get the curve ID as the attribute. And paste this in. We'll now have unique colors for this, right? So then from here, map range of this. You know, it's going from 0 to 19 because that's the number of instances for it. Now it's going exactly like this. And if we do mix color, we can have this. And let's just do a darken. Will this work? Yes, it will work. Base color. Emission. Yes. So now each tendril is a unique color. That's much better. I'm happy with this. It looks a bit more unique now. And then the colors can change however we want. Cool. This is the basic effect. It's done. Thanks for watching, guys. And I look forward to showing you guys the next one. I think the next one, what I'm going to do is I'm going to do collision detection. So that as these kind of points go after this guy right here, so as these go after this guy right here, I'll try to avoid obstacles. And I hope to see you guys in the next one. Thanks so much for watching, guys.
Augury.